My name is Victor Naumov, and I work in the scientific department, RIPE NCC. I am in charge of the development of the Atlas probing network, and the RIPEAtlas is a unique probing network which is made up of compact measurement devices, which is to cover the entire globe, which is being built together, and we really hope that you will help us create this network. In my presentation, I will speak about network monitoring. A lot of you have heard about Nagios and Isinga. And we know that these devices can also be used together with RIPEAtlas via API, which gives you a chance to use a lot more measurement points than over the use of the routers. And you can also look at your network from the outside and initiate different alerts in this process. The RIPEAtlas integration in Nagios is simple, or Isinga for that matter. You just need to follow the 3 simple steps. Create a RIPEAtlas ping measurement, go to status check URL, and add this URL to Isinga or Nagios configuration. First of all, you create the UDM measurement. It is set by the user. You follow the normal practice. For this, you will need to log into atlasripe.net, go to My Atlas and Measurements, and choose New Measurement or One-Off. Choose the number of probes that you would like to use there. Set the type, target, and frequency of probes and measurements, and choose your region as well as other functions that you will see there. Status check currently supports only ping measurements. You can also set probes automatically. For this, you will have to use the REST API. While doing such probes, you earn credits. When you do probes, you use credits. The use of credits is preventing the overloads in the RIPE network environment. Each probe would cost you a different number of credits. For example, ping costs 10 credits, trace routes cost you 20, etc. And it depends on the frequency, and it depends on the number of probes. The credits could be earned when you host a probe. If you are a RIPE NCC member, or if you sponsor a large number of probes. As soon as the probes are taken, you request a URL, do the status check measurement where you show the ID of your particular probe. JSON structure will return to you containing the RTT, packet loss, etc. You will also set thresholds of probes for the number of the packets, for the number of probes, for the number of the packets lost, for the RTT changes. The result will be put in the HTTP reply headings. You might want to find more details in the documentation section at RIPEAtlas website. The third step is to configure the probe in Isinga or Nagios in check HTTP plugin, or use the available configurations, use presets at HICHub. Just copy paste it and add your parameters. The next tool is the DNS monitoring, DNS Mon for TIL DDNS. You might have heard about this tool already. You might have used it. It's a new version which is RIPEAtlas based. It's the reincarnation of the older DNS tool. It does not support all the TLDs, but it monitors all the root servers. In the future, we are planning on adding more TLDs there. A few words about RIPEAtlas development. Today we have more than 5,800 probes connected. We have 8,000 users, active users this year. Every day we'll run 5,000 plus measurements, which are user-defined. By the end of the year, we are planning to have expanded to 10,000 probes. The probes are shown here. These are the measurement devices. The obsolete versions that I showed previously are no longer in use. Instead, we use version 3. The TP-Link router with our software installed, as well as the Anchor server, RIPEAtlas Anchor, which is a more powerful probe, allowing you to use it as a target. Today we have placed more than 58 Anchor servers. By the end of the year, we will have launched 100 of these Anchor servers. RIPEAtlas is widely used to resolve various networking problems, and our users would regularly publish their reports on how they used the RIPEAtlas, helping others to resolve similar issues. For instance, how they were resolving the problem of slow servers in British Telecom, packet loss issues, etc. There was a very interesting presentation at the last RIPE meeting about the black holing. It was done by Job Snyders. And there was a very interesting document by Stefano Bortsmeyer, where he studied the use of the L-root instances and their geographical coverage, which may be sparse in one places and more dense in the others. RIPEAtlas will be expanded. Unfortunately, we don't have too many resources available to do everything you would like us to do. So therefore, we set the priorities first in this process. And the next thing we would like to implement would be the probes and measurements selection, so that you select some of the probes for your own measurements and launch a measurement from the marked probes or tagged probes, for that matter. Extension headers have already been implemented, although we have had some issues with extension headers and we are currently resolving them. We will provide you the more accurate selection of IPv6 probes for IPv6 environment. We are currently working on distributing the probes. We increase probe distribution via RIRs, RIRs, and now I encourage you to use our network. Please connect and place probes. We're interested on not just putting the probes in the western part of Russia, but also in the eastern part. Unfortunately, we don't have a pretty good coverage in the east. If you are a programmer, if you have developed your own practices of the use of APIs, data analysis, please do put it on our hub and please check other users' examples there. Please become an ambassador, become the ambassador for probe distribution. Unfortunately, we would not be able to distribute probes on our own, so we need your help with that. How to become an ambassador? It's quite easy to learn on our website. If you become an ambassador, you will support the probe distribution. RIPEAtlas is available. Please follow this very simple URL, atlas.ripe.net. Mailing lists for active users are available. Please ask questions and use our Twitter. I don't have too much time for my presentation, therefore I just briefly explain the RIPEstat. RIPEstat is a unique thing. It's an abundant source of information with a very simple user interface. It has a reverse DNS data, RIPEAtlas measurements, registration data, RIPE database. It gathers information from external resources. Routing, reverse DNS, block lists are available there. You may search by IPv4 addresses, IPv6 addresses, prefixes, autonomous system numbers, search is supported, etc. Please use it, you'll get plenty of information from there. RIPEstat was used in the assisted registry check. Axel spoke about that. I will skip this. Therefore, RIPEstat does not allow us to monitor the network in real time, but it allows us to investigate different incidents that had occurred before. Here you can see how the prefixes were used. Here you can see the BG play. You might be familiar with BG play. It's the Indonesian incident visible in BG play. You may want to use it for seeing how the routing changed over time. On YouTube there's a video, a very geeky video on how Pakistan Telecom was trying to, how YouTube was hijacked by Pakistan Telecom. RIPEAtlas availability is available at RIPEstatus. Please check whether there's certain activity going on in a certain region. RIPEstat is growing. We add more information from a bigger pool of resources. We increase and enhance its stability, and we welcome your feedback and suggestions how we need to develop RIPEstat in the near future. Any questions? RIPEAtlas ambassador. Have you thought about motivating RIPEAtlas ambassadors for giving them credits for each probe they add? Good question. I think we'd better provide more credits if ambassadors check and verify that these probes really have been included, for the probes that have really been included in the network, because ambassadors will immediately have a need to talk people into including these probes in the network. May I take a minute of your time about anchor servers? We have brought an anchor server to give it to the administrators of the MSKIX, the sponsor of this, one of the sponsors of this event, and we're interested about the proper distribution so that you also use these anchor servers and install them. And Alexander Ilyin may help you with that if he's present here. By the way, I'm going to show it to you. Why do we need an anchor server? Why do we need an anchor server? It's a big probe, in simple words, which will of course use more traffic, which requires the mandatory IPv6 connectivity and will cost you more money. It's not a free of charge solution as a probe. So you'll pay this money for hardware. You're not going to pay for use, but you're paying you money for the hardware, and you put it in the point of presence. The probes around you will be measuring you, so you'll be the host for these probes, and the probes will monitor you and your traffic, and it gives lots of benefits.